blow your homework away. The effect of airspeed on paper trajectory. Literature review. The first website that I used was www.engineeringtoolbox.com. I use this source because it shows over 4 different types of fans and the different types of fan blades that are used for these fans. It also shows which fans and fan blades are better for different things, along with what the different fans are used for. This website relates to my project because it describes the types of fans and fan blades that I used for my project. The online encyclopedia that I used was from www.nationalgeographic.org. This source was used because it talks about anemometers and the different ways that they can be used and the way that an anemometer works. It also talked about what different types of anemometers are used for, like how NASA is using an anemometer to get a better view of Venus. This source is related to my project through the fact that it gave me more information on the type of anemometer that I used for my project. Literature review continued. The first online journal that I used was from www.sciencedirect.com. This source was chosen because it tells me about fan types, characteristics, and history. It also talks about how the airspeed from the fan changes when the airflow is blocked. My project is related to this source because it talks about how different fan types work and about the power behind them. The second online journal that I used was from physics.stackexchange.com. I chose to use this source because it talks about what is going on in front of and behind the fan. I learned that if you put your hand on the back of the fan, the airflow is blocked and the fan's airspeed changes. My project and the source are related through the fact that it helped me realize that when I put my hand on the back of a fan, it may be altering the results of my experiment. How does airspeed affect paper trajectory? Hypothesis. If there is a lower speed, then the paper will travel a shorter distance because a higher air velocity is needed for the paper to travel a longer distance. Variables. Independent variable. The air velocity output by each fan setting. Dependent variable. The distance the paper will travel. Constants. Paper type, surface, height from floor, start distance, and fan size. Materials: white multi-purpose printer paper, blue painter's tape, measuring tape, 60-degree geometric triangle, Smart Devil USB desktop fan, handheld fan, kitchen table, anemometer, and phone timer. Procedures: 1. Place a piece of painter's tape at the edge of the table with a mark on it so you know where to position the fan, and a second piece 36 centimeters from the first piece towards the middle of the table. Make a mark in the middle of the second piece. This mark will be where the paper starts each time. 2. Place the shorter edge of the piece of paper at the start mark on the second piece of tape. 3. Draw an arrow on the paper to the edge, pointing to the start point. The distance the paper travels is the measurement between the start point and the tip of the arrow. 4. Take the geometric triangle and place the beginning of the 60-degree angle at the edge of the table you have marked for the fan. Lean the fan onto the triangle so it will be at 60 degrees, then remove the triangle. Hold the fan in place. 5. Turn the fan to the first setting and start the timer for 30 seconds. 6. At the end of 30 seconds, turn off the fan and use the tape measure to measure the distance from the start point to the tip of the arrow. 7. Record the results in the data table. 8. Repeat the experiment and record your results 2 more times for each setting. 9. Repeat steps 1 through 8 for the second fan. Fan number 1, which was the handheld fan, had on the first setting an output air velocity of 3.0 meters per second with an average distance of 0.0 centimeters. For the second setting, the fan had an output air velocity of 4.0 meters per second with an average distance of 28.7 centimeters. For the third setting, it had an output air velocity of 4.9 meters per second with an average distance of 102.5 centimeters. Fan number 2, which was the Smart Devil USB tabletop fan. The first setting had an output air velocity of 1.5 meters per second with an average distance of 0.0 centimeters. For the second setting, it had an output air velocity of 2.0 meters per second with an average distance of 4.1 centimeters. For the third setting, it had an output air velocity of 3.5 meters per second with an average distance of 98.9 centimeters. Data analysis. The results of my experiment were mostly as I expected. At the lowest setting on both fans, there was 0.0 centimeters of movement. On the second setting, with a slightly higher air velocity, fan number 1 was able to move the paper an average of 28.7 centimeters, and fan 2 only an average of 4.1 centimeters. With the third setting, in the highest air velocity, both fans were able to move the piece of paper off the table to their furthest average distance traveled. Fan number 1 at 102.5 centimeters and fan number 2 at 98.9 centimeters. The data showed that during all three trials, on setting 1, the lowest air velocity, both fans were unable to move the paper at all, and that on setting 3, the highest air velocity, the average distance traveled was highest for both fans, proving I was correct in my hypothesis. Conclusion. My conclusion of how airspeed affects paper trajectory is that if there is a lower speed, then the paper will travel a shorter distance because a higher air velocity is needed for the paper to travel a longer distance. What I have learned from this experiment is that more airspeed means more movement. This experiment could help you if you ever need to literally blow your homework away. All you need is a fan with the right amount of air power. If you do decide to do an experiment like this one, I suggest having a very flat surface, a steady hand, a longer, less round table, and some sort of walls on either side of the paper to make sure it has a straight trajectory.